Hola!
Hello.
¿Qué hora es?
Wednesday, 14:55.
Do I need a coat?
Current temp, 33.24 degrees. High, 37.15. Low, 30.11. Clear sky.
Is it late?
Wednesday, 14:55.
Tell me something funny about Louis Rossman.
Louis Rossman once said, "My MacBook's touch bar is like my ex-girlfriend, always showing me options I don't need and never giving me the one I want."
Well then. Adios.
Goodbye.
Welcome back. As you know, I am Eli, the computer guy, and in today's class, we are going to be going over using the OpenAI API to create a decision tree for your voice-controlled computer. So in the last class, I showed you how to create a voice-controlled computer that could do a number of different things. It could communicate with the operating system to pull whatever the current time was and tell you that time, actually speak to you what the time was. It could use a REST API to be able to go out to the internet and to be able to get a weather report for your current area. It was able to actually turn a lamp on and off using an Arduino and a relay. And if you wanted to, it could then tell you a joke using OpenAI. Basically, you could say, tell me a joke about Louis Rossman or whatever else, and it would go out to OpenAI, and it would then actually speak that joke to you. Now, when we did that, one of the interesting things that we did is we used the Google's basically speech services, and what we were able to do is we were able to turn your speech that was coming into the microphone of your computer into text. And then basically we could parse that text and look for specific words. We could then use an if-else statement, or actually an if-else statement. And if specific words were stated in the phrase that you had said, basically that would fire off a specific function. So if joke was somewhere in the phrase that I said, it would fire off the OpenAI joke function. If light was in the phrase that I said, it would turn the light on or off. It would basically go out to that function, right? Well, one of the problems you get to in the modern world is people say things differently. Like one of the big frustrations as computer people is there are literally hundreds of different languages that exist, and beyond that, people have their own way of saying a whole bunch of different stuff, right? Language is a real pain in the butt for computer people because basically here's the deal, right? If you say the exact statements that we want you to say, we can then parse, we can read those statements, and then we can fire off certain function or events to happen, right? That's pretty easy. Again, light on, I can look for light on in a phrase and turn a light on. Light off, I can turn the light off. But here's the thing, people aren't like that. People aren't like that. You tell people what to do, and I guarantee you, they're not going to do that. They're going to do anything else. And so one of the problems you have is when you have people that are going to be speaking to your robot, basically to your computer control or your voice controlled computer system, they're going to be saying things in all kinds of different ways. And so one of the interesting things that you can do with the OpenAI API is you can actually feed all of your functions to the API call as a string. So I'm going to show you that here. Basically, we have all of our functions, all the functions that we created, they're in a single file. Basically, we're going to read from that file and turn that into a string variable. And then when we make a request from OpenAI, basically we're going to send all of those functions to OpenAI. Plus, we're going to send the phrase, we're going to send the query that the person is asking. And then basically within our little OpenAI statement that we're creating, we're going to say which is the best function. Out of the functions that we are giving you in this variable value, in the string, which is the function that should fire off based off of what this person has said. It will then return the function that should fire off. We then have if-else statements, basically, that look for a specific function that's coming back from OpenAI, and then that will fire off the function from that function file. And so that's with this, like I say, when I was showing you in the demonstration, things like the weather. If I specifically tell the computer, what is the weather, right? I can parse for that. If person says, what is weather? Give them weather report. But what if they say, is it cold? What if they say, is it hot? What if they say, should I wear a coat? What if they say, should I take an umbrella? Right? Think about all of these things and imagine, right, as a coder, as a technology professional, imagine if you had to hard code every possible query somebody might ask for. That would be an utter pain in the butt. One of the nice things with the OpenAI API, though, is again, you can send that query from the user up to OpenAI API. You can send all the functions, and then you can just ask OpenAI, hey, what the hell are these people asking for? So this is one of the things that I really like with large language models. Now you're going to hear a lot, right? In the modern press, at least in the 2024 press. By 2025, everybody's going to forget about LLMs. But in 2024, right, we hear about LLMs are going to destroy the world, and LLMs are so powerful, and LLMs are going to take your job. The funny part is, if you actually sit down with any of the people that are telling you that LLMs are going to destroy the world, and then you ask them how they deploy LLMs within their environment, they'll most likely ask you what an environment is, right? One of the big problems we have nowadays is, again, people want to think AI is this dangerous, powerful thing, but they don't really want to think about what they're going to use it for. Yeah, but how actually are you going to use this? And one of the things that I've talked about for a long time is I like LLMs. Now, to be clear, I'm going to say something controversial here. I really like LLMs. LLMs, large language models, provide a tremendous amount of functionality for being able to parse human communication. If you're trying to figure out what the hell humans are talking about, LLMs are a great way to go. Are they going to destroy the world? No. Are they more dangerous than nuclear weapons? No. Is their use case surprisingly small? Yes, right? And I think that's one of the things you need to be thinking about with any of the kind of this technology that comes out, whether it's artificial intelligence, whether it's quantum computing, anything else, is basically how does this fit into your system that you're going to be building out? So you're going to be providing an overall solution to a customer. That solution is going to be built from 10, 20, 500 different subsystems. And one of the things you need to be thinking about is basically how does AI fit into this? Or how does, more importantly, large language models fit into this? And the way that I look at it, again, is that basically large language models are essentially regex for human language, right? Being able to go in and grab the information that you want. When I really started to be impressed with large language models, it was actually parsing PDF files. So you don't think about this, but PDF documents, not only are they text documents, but they're also a visual document, right? All of these blocks and different areas and that type of thing. Even if it's like a 1099 form, even if it's a government form, there's actually a visual component. So one of the interesting things with Python, right, there are modules in Python that will open a PDF, basically scrape out all the text, and provide you the text. Well, here's the funny thing. It will give you all of the text. All of the text will be there. Oh my God, it's a disaster. It's like all the text is there. Oh, it is just a mess, right? Because when Python is going through and is ripping out the text, it's just ripping out the text. And again, you got this visual component, so stuff is all over the place. So one of the nice things with using the OpenAI API is you can pull all this text out of a PDF. You just get a mess of text. And then you can just send that up to OpenAI and you can say, can I have this person's first name, last name, telephone number, social security number, address, and whatever else? And it will just provide you those results, right? It's able to go in, from this mess, be able to pull out the information that you care about, and then just give you that information back. But again, think about that. Even with the system that simple, that's a very simple system, right? You got the PDF files. You have to somehow get the PDF files into the system that your Python script is actually able to interact with it on. You then have to have this PDF to text module that then is able to read the PDF files. That then turns that information into text. You then have to send that information up to OpenAI. API will then send a response back. So you got a response. One of the things you got to think about, what do you do with that response? That's then got to be sent into a data store, most likely some kind of relational database, that type of thing. And then there has to be a user interface so that users actually find this thing to be of value. So again, even think about that, right? We talk about AI. Even in that system, AI is one component of a much larger, much more sophisticated system. And this is the thing that I really want you to be thinking about, again, with any of this stuff, whether it's AI, whether it's quantum computing, IoT stuff, whatever else. So anyways, basically, in the class that we're going to be doing today, I'm going to be showing you how to use OpenAI to determine what function basically somebody is asking for when they're communicating with a computer, so that you can have a much more human style of communication with a computer versus having to say very, very, very specific trigger words. Now, we have two versions of this communication script that we're going to be dealing with today. We have the speech version. Basically, this actually has the Google's speech services built into the script so that I'm able to talk verbally to the computer to be able to interact with it, and it talks back. I also simply have a text input function, right? So basically with this one, to make life easier and make it so you don't have to scream at your computer and your computer doesn't have to scream at you, all we do here is our query is we use the input function. It asks, how can I help you? And then you simply tippy tap out what it is that you're asking for, and then it will print that on the screen. I'm going to be using this mainly today for the demonstration just because it's a lot easier than actually trying to talk to the computer. Again, that's one of the things you need to be thinking about if you're going to be building out systems is you can build out most of your system and then have the UI be something that's good for a testing environment. And then once you figured out the functions and the API calls and all the sophisticated stuff, and then you can slap in the final voice component or something afterwards, right? Because trying to talk to a computer is a little bit quirky. It's a little bit janky on the best of days. So knowing what you literally typed in can make life a lot easier. Like, so for this, basically, if I hit the go button on this, basically says, how can I help you? And I can say K or S, right? So basically what time it is in Spanish, and it simply gives me Wednesday at 15:11. I can say, do I need a coat? It says, so it brings back the get weather function, and it says the current temperature is 33, kind of high today, or kind of cold today, high of 37, low of 29. It's a clear day with a clear sky, right? Do I need an umbrella? Right? Goes up, again, basically gives me the weather. Again, so I can ask all of these different connotations of the concept of something like weather, and it will simply give this back. So again, it makes it much more fluid to be able to communicate with your system. Again, I can say, instead of just telling me a joke, I can say, tell me something funny about, I don't know, cars. Right? And then it goes, gets the joke function. It then sends the value, tell me something funny about cars. Message, why did the car bring a blanket to the party? Because it wanted to make a cozy couple. Anyway, it's AI. It's AI. What do you want me to say? So with that, let's go over and take a look at the AI function script. So in my main script here, right, this has the input function. This is the script that we're actually interacting with. You're going to notice at the top, we're going to import OpenAI module. You know, that gives us our AI functionality. We're going to import the OS module because we need to actually be able to interact with the OS. But one of the things you're going to notice here is import AI underscore function. So what this is this is a Python file that is in the same directory as this particular script. And basically what we're going to be doing is we're going to be importing this file and using it as a module. If we go down to where our function calls are, we can see answer equals AI underscore function dot hello. Answer equals AI underscore function dot goodbye, don't understand, get time, get weather, dot get joke with the query, right? So basically what we do is we have one single file that has all of our functions. We're going to import that here, just like we would import a module, and then we're going to be able to call the functions within that file down here later. Now the reason that we're creating our own separate file is because what we're going to be doing is we're going to actually be opening this file, so AI underscore function. So this right here, so current directory, this gets what the current directory is, and then we have the file name, and then we join the current directory with the file name, so that makes sure it doesn't go to the root directory. Remember in Python, by default, everything goes to your user root directory, right? So the Eli home directory, everything that I'm going to write, if I'm going to create a file, it'll automatically get written there. If I'm going to read a file, it's automatically going to look there to read the file. So by doing this, the os.path.directory name, blah, 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 this will make it so we look in the same directory that this particular script is in. And so what we're going to do is we're going to open this AI underscore function .py file right here as read. Then we're going to have the file underscore function is going to equal file underscore function .read. So we're actually going to read this file into this variable value. And then down here with this OpenAI query, we are going to send basically that entire file to OpenAI as basically saying this is all of our functions. Again, which function do we care about? If we go over to the AI underscore function file, we're going to see we have some modules that are imported here that we need for the functions that we're going to be firing off. So import date time. So date time is used in order to get the time. So we need that. Import requests. We're going to be doing a REST API call, right, in order to get the weather. So we need requests. Import OpenAI, because within this, that joke function requires OpenAI. And we come down here, client equals, this is basically for OpenAI. We feed it the API key. I'm not going to show you that today. Your API key either would go here, or you would create what's called an environment variable for that API key. We're going to be using the REST API for what's called open weather in order to get the weather information. So that API key would go here, and then we can simply go down and take a look at the different functions. So basically, again, to make this a little easier for OpenAI to understand, we do comments before each function to kind of say what the function is about. So hash say hello. We're going to do define hello, message equals hello, return hello. So if I say hola, it'll go, oh, this needs the hello function, and then hello will be returned, and it'll tell me hello. If I say adios, it'll realize it's the goodbye function, and the message will come back as goodbye. If it's I don't understand, it doesn't know what the hell I'm asking for, it'll say I don't understand. You'll get that back. We come down here. These are some of the functions that we saw before in previous classes. So the get time function. So with this, what we're going to be doing is we simply interact with the operating system. So we use the datetime module, datetime function, now method. That is going to return what the current time is that's on our computer. Message is then going to equal this mess right here that basically gives us the day, the hour, and the minute. And that gets turned into a string, and that will be the value for message, and then we're going to return message as the value. So this is going to return time for us. For weather gets a lot more complicated because we have to make multiple REST API calls. So the first thing that we need in order to get the weather is basically we need to figure out where we are in the world. How do I know what the weather is here? I don't need to know the weather in Dallas. I don't need to know the weather in San Francisco. I need to know the weather in Asheville, North Carolina. So first thing with REST API call we're going to do is we're going to get our current IP address. What is our external IP address for the building, for the facility that we're in? So we're going to do request.get api.ipfi.org.text. So basically we're going to bring this value back as a text, and it's going to give us 26.87.101.92 or whatever else. That's going to be our external IP address. Once we have that external IP address, we can use that to get geographic information about where we are. So there are databases out there and there are REST APIs that allow you to pull geographic information about your specific IP address, more or less where you are in the world, more or less what your latitude, longitude is, your ISP provider, a whole bunch of different stuff. So we're going to be going to ip-api.com JSON with that IP address that we pulled in. So IP data equals request.get fstring ip-api.com JSON with that IP address .json. So we're going to bring that back as a JSON format. So the IP address we bring back as a text format, and this we bring back as a JSON format. And the reason we want the JSON format is then we need the weather. So for the weather REST API, we need our latitude and we need our longitude. We don't need our city, we don't need our state, we need our latitude and longitude. So we can get that from this IP data. So weather equals request.get api.openweathermap.org data weather lat equals IP data lat and long equals IP data long. And units, you put this to imperial. So if you forget this, you'll get Kelvin. I have no idea why OpenWeather does this. It defaults to Kelvin. It doesn't default to Celsius, doesn't default to Fahrenheit, it defaults to Kelvin. So anyways, you put units equals imperial here, so you actually get Fahrenheit if that's what you're looking for. And then here we plug in the API key for weather, and then we pull back the JSON. Then message is going to equal fstring current temperature equals weather main temp. So this is what the current temperature is, degrees. High is going to be weather main temp max. Low is going to be weather main temp min. And we do a next line, and then weather 0 main. So this basically just gives you like a default thing for what the weather's like, clear. And then weather 0 description gives you a little bit more of a description. So clear sky, cloudy sky, drizzly, that type of thing. And then that's going to get returned as a message. So basically this is that weather call. And again, this is what you need to be thinking about as a technology professional, is how you build step by step to get the data that you care about. I want the weather. Okay, well, in order to get the weather, I'm going to need my latitude, longitude. Okay, well, this IP-API can give me latitude, longitude, but I need my IP address. So, right, we do a request for my external IP address. Then we do a request for this geographic information. And then we do a request using the latitude and longitude. Once we get that information, then we can pull from the JSON response for the weather. And that's how you build up these systems. And that's why it's important to really understand how these systems work and really be thinking through the overall process. We then come down here to, get a joke. Define, get joke. Here we're actually going to pass the phrase. So not only are we going to ask for a joke, but we're going to ask for a specific joke. I want to joke on cats. I want to joke on Louis Rossmann, right? So that has to be passed. And so we're passing that here as the phrase. Response equals client chat completions. Create message. Systems, your comedian, assistant, answer in less than 25 words. This is an important thing. If you don't say things less than 25 words, you might get 1,000-word joke response, which you probably don't want. And then user is, we're going to pass the phrase. So you are a comedian, answer in less than 25 words. Tell me a joke about whatever else or make me laugh, so on and so forth. Message equals response.choices 0.message.content, and then we're going to return that message. So this is the entire AI underscore function script that we've created. And so we are both going to be calling to this particular script, and we're actually going to be reading this entire script into a string and sending that up to OpenAI. OpenAI. So now we go back to the main script. So this is the AI-decision.py script. So this is where we're going to be inputting text. So this is not this speech script that I initially showed you. This is where basically you just get that input. You type in K or a S or whatever else, and it gives you the response. So basically with this script, it's all pretty simple. If you actually take a look at this, you'll see that it only comes out to about 50 lines of code. because we separated the functions off into its own file. So here we're going to be importing the OpenAI module because we need that in order to do the parsing of the query that the person is going to be saying. We're going to import AI underscore function. So we're importing this file so that it's accessible down here so that we can actually fire off the functions that are within that file. AI underscore function, get time, get weather, get joke, so on and so forth. So the first thing that we need to do is we need to import this file as if it's a module. So this also needs to be within the same directory as our script so that it works properly. We're then going to import the OS module so that we can do this whole mess with getting what our current directory is. So simply the import AI function here, if this is all you're going to do, you simply put the file into the same directory that the script that is running is in. Then if you're trying to read from the file later, that's where you need to go through this whole os.path thing. Here we're going to do client equals openai.openai, API key equals, and whatever your API key is. So basically, when we make that OpenAI call down here, this is going to be client, and so it's going to need its API key, and this is where we're going to feed it its API key. Then this is the mess that we're going to use in order to turn that AI function script into a variable value so that we can send it up to OpenAI. So current directory is going to equal os.path directory name, os.path absolute path underscore underscore file underscore underscore, close out the parentheses. So this is going to get the current directory that you're in, not the current working directory. Current working directory basically is generally your root directory. We don't want that. We want the current directory that we're in because basically this script is running here and we need to open up this AI function script that's in the same folder. Now, do remember again with Python, your root directory is almost always going to be the user home directory. So if you don't do this, you would have to put the AI underscore function in the user root directory too. That'll just be a mess. So anyways, this is how we get the current directory. We have the file name. We know what the file name is. File path equals os.path.join current directory file name. So what this does is this formats the path properly for your operating system. So there's different ways you could do a file path, but one of the things you have to realize is different operating systems use forward slashes or backslashes for the path to things like files. So if you hard code that and then you move your script from Windows to Mac or from Mac to Linux, you might run into problems. Using this join here, it will format everything properly for whatever operating system your script is currently running on. Then we're going to go down here. And with this is where we're actually going to turn our Python function script into a variable value. So with open file path, so we're going to go to whatever the current file path is, AI underscore function, read, so we just want to read, we're not writing to it, as file function. Then file function is going to equal file function.read. So when we do this initially, this is going to be an object. So it's going to be an object. And if you try to do something with it, you're just going to get this object thing. So you need to do read. We need to read the object to turn it into text to send it to a variable value. So file function is going to equal this file function that we created here, dot read, and then this is just going to be a whole bunch of text. We're now going to go down here to the while true loop. So I do while true loops with these just so it can keep going. If you don't do a while true loop, it'll run once, and then you have to restart the script and restart the script. The nice part with this is it runs after it gives you a response, it will make a new request. After it does a response, it'll do a new request. Again, a while true loop. Query equals input, how can I help you? So when I run this script, it's going to say, how can I help you? A couple of spaces, so you can type out whatever your request is. And then there's going to be os.system_clear. This is going to clear the screen. Basically, it's going to make the screen look a little bit better. So it's going to say, how can I help you? That value is going to be taken in as a variable value for query. It's then going to clear the screen. It's then going to print out new things on the screen. And then when you do your new submission, it'll clear the screen again. So this way, you're only looking at 4 or 5 lines of text instead of just this ever increasing mess of text, right? If exit in query, so this is query, if I say exit, it'll break. So it'll break out of the loop. The script will stop. Here, we're then going to do our call to OpenAI. Response equals client.chat.completions.create. And then we have messages. So this is different, just so you know. The OpenAI API call has changed within the last 6 months. In order to do this class, I had to re-edit a whole bunch of code. One of those things to keep in mind, like the messages is the same. The actual request and then how to get the response is a little bit different. This is fine for now. Whatever we're doing this, January 2024, this will work fine. If you're doing this in January 2025, just realize the concept may be the same, but the actual code might be a little bit different. So role, system, content, you are assisting in choosing the most suitable Python function for a user request. So this is the system role. What is the system? What character is the system playing? That's what you do here. Then you can only have one system role. You can have multiple assistant roles. So assistant, you will be provided with available function names for this program. Assistant, please only provide the name of the function without additional information or responses. Assistant, do not provide any response other than the correct function name. So one of the things you're going to find with OpenAI, you got to be real specific. You got to be real specific. When you're dealing with OpenAI, it's like the intelligence of like a 5-year-old. A 5-year-old will be like, you didn't tell me I couldn't. You're like, I didn't think I had to. So that's gonna be the only thing. Like when you use like OpenAI or any kind of large language model system, you do have to play with it a lot because it is amazing how quirky the systems can be. Even like with this, what's interesting because we print out the responses. Like whenever I do this, I do the request, then I do the actual OpenAI response, and then I do the function response. I do that for troubleshooting purposes so I can try to make sure I understand what's going on. One of the things is when you get that OpenAI response, it's like 1 out of every 10 times, I don't know what the hell it is. It just goes off on a tangent. So anyways, you got to write a lot of this stuff to try to keep that whole tangent thing down. We then come down here to the assistant content, and this is where we feed file_function. So this is where we're going to feed all that function that we have in this file to OpenAI to say these are the functions that we got, right? What do we need? The nice part about doing it this way is that you don't have to go and create like a different file or a different type of thing. It's not like you create all of your functions in one file or in one place, and then you have to type out all of those functions in a list or a dictionary or something like that, some other place, and then you might get into a problem where they don't match. The nice thing with this is you're just feeding it all of your functions as they are. So as you add functions, those functions get added. As you remove functions, those functions are removed. You don't have to do any other, editing process. Role user, so this is the request from the user, and that is going to be the query. This is going to be K or S. Do I need a coat? Whatever else, that's going to be there. We're going to go down. Model equals GPT 3.5 Turbo. GPT 3.5 Turbo is the cheapest way to go. Again, it costs you 1/5 of a penny for every 1,000 words or something. And honestly, I've got to say it might be better than 4 for some things. I got to say, OpenAI's API is weird. I've used the 4 because that's what some people say. Well, the 4 is more expensive, but it's better. I don't know. Maybe in some circumstances. Not always. So I find 3.5 Turbo is not only cheaper, but it actually works pretty darn well for what I'm looking for. So response. So this is going to be what's going to be coming back. Response equals response.choices 0 message.content, right? So you're going to get this whole response back from OpenAI, and this is how we get to just the content that we want, right? So we have the response up here. Response equals this whole API call. And then from that, I just want the content. I just want the message returned. And then here, I'm going to print OpenAI response and what the response is. We're then going to go down to our if statements. So if hello in response, right? So basically if the response that comes back from OpenAI has hello in it, we're gonna fire off that hello function in the AI function script. Goodbye, we're going to fire off goodbye. If understand is in the response, we're going to do I don't understand. If time, we're going to do get time. If weather, we're going to get weather. If joke, and we're going to get joke, right? And so basically this is what we're doing. So OpenAI is going to send back the function that it thinks we want, and then we're just looking for specific words from that function to then fire off the actual function that we care about in this if statement. We're then going to print out what the message is. So answer equals AI underscore function dot get joke query. So again, since this is a joke and we want a specific joke, we're going to send the query to the get joke function, and then we're going to get an answer, and that is going to get printed on the screen. And so with that, I can hit run. It says, how can I help? And I can say, tell me something funny about AI. And then it's going to go. So OpenAI response, get joke. What it's going to be sending to that get joke function is tell me something funny about AI. And then message is, why did the AI go on a diet? It had too many bites. And then it asks you, how can I help again, right? I can say, K or S. So when I do this, it'll then clear that. See, it clears the screen. The AI response is get time. The message is Wednesday at 3:42, right? And so that's one of the nice things. That's one of the things you have to be thinking about too with like user interface design. It's not just for the users, right? Everybody thinks, oh, the users. It's also for your own sanity. Having a nice clean screen here just can make life a lot better, right? Do I need a coat? And so it goes, it's get weather. So basically with that get weather, right? So OpenAI is giving a response of get weather. We're then in this if statement. And so basically what we're looking for, if weather, AI function dot get weather. And that's what gives us, what the current temperature is, whether the sky is clear, whatever else. So then, to add speech recognition, basically speech services to that script that we created, basically what we're able to do is we're able to add the speech recognition module. So this is a package that you can install with pip3 and GTTS, Google Text-to-Speech Services. So speech recognition will turn your voice into text. GTTS will turn text into a voice. And so from GTTS, import GTTS, import speech recognition as SR. So this is an alias, so it makes life a little bit easier. Language equals English, and then R equals SR dot recognizer, right? So basically we'll be able to use R as a variable value to call the recognizer function. Current directory and all that is the same as before, while true. So here we're going to make answer equal nothing and query equal nothing. So basically one of the problems you can run into with these loops is if the variable value carries over from the previous loop. With like these speech services, it can just be a mess. So by blanking out these variable values here, it just makes it so you don't keep getting a repeat answer for some weird reason. Then we come here, so we say with sr.microphone as source, print say something, as we saw before. Audio equals R, so that R we created, dot listen source. Right? So sr.microphone as source. So the microphone as source, we're going to listen to the microphone and we're going to send that to audio. We're going to try. So query now, instead of being the input function, is going to equal r.recognize underscore Google audio lower. So this is the standard statement for basically sending the audio that we got in to Google. The next thing that I do is I use a method lower. So what lower is going to do is everything that gets returned, it's all going to be sent to lowercase. So again, one of the things you have to be thinking about when you're parsing text is uppercase is different than lowercase. The other thing you have to remember is AI is quirky as hell. And so sometimes you get some really weird capitalization when you're getting a response from OpenAI that doesn't make a darn bit of sense. So if you force everything to be lowercase, then you know at least everything is lowercase. So you could do upper. If you want everything to be uppercase, you can make it uppercase. I'm doing lower here so that all the text that's coming back from Google will be in lowercase, and that's going to be sent to query. And then here, we're just going to print that query out to make sure that the computer is hearing what we think it should be hearing, right? There's some except here. So if there's an unknown error value, it's going to simply print out, I do not understand. If there's a request error, so basically it can't get the information from Google Speech, it'll also print out an error here and give you some additional information. So this is an error of I don't understand what you're saying, some problem like that, this is an error of the speech services are not functioning for some reason. Same thing, os.system clear, so it's going to clear out the screen once you make the request. If exit and query break, basically the exact same OpenAI API call that we had before. Response is going to equal the same. If else, elif statements are going to be the same. And then down here, this is where we're going to try to turn the text response we get back into speech. So try my obj equals GTTS, text equals answer. So the answer value that comes back, that's going to be text. Language equals language. That was that variable value we set before as English. So it tries to translate it into English. Slow equals false. So it'll say it at the normal rate. My obj.save response.mp3. So it's going to turn answer, this answer text, into audio, and then it's going to save it as an MP3 file, response.mp3. You'll notice here there's no paths, there's no join, there's no OS. This is simply going to be saved in your default root directory, which should be your user root directory. Again, because I don't care. This should be a disposable thing. It should just get played, and I don't care about it. If you care about it, you might do that whole os.join thing to dump it into a specific folder that you care about. os.system. So this is going to basically call AF Play. So I'm doing this on an Apple computer. I use an Intel-based MacBook Pro for this particular class. There's a audio player called AF Play. So it'll use AF Play to play response.mp3, and that is what will actually basically speak the response to us. And so that's the class today on how to use the OpenAI API in order to create a decision tree for requests coming from your users, right? So the big thing, again, whenever you're coding anything out, nothing in the computer world happens quote unquote magically. Somebody's got to write something down somewhere, right? So if you think about this with things like personal assistants, if you think about a few years ago, if you don't have AI, literally somebody would have to type out every possible request a user might make and then associate that with a specific function, right? So you may have some database literally of thousands of different requests all pointing to different functions so that if people say a specific set of words, that will trigger that particular function to fire off. And now that's a lot. That's a lot of tippy-tap typing. That's a lot of typing there. And one of the things I'm going to tell you is that good geeks should be lazy. Geeks are weird. We are weird. It's like we are lazy, but then we also work a lot at the same time. So like any particular project, any particular task that we do, we should be as lazy as possible doing that task. But then we overload ourselves with way too many tasks. So it's kind of, again, welcome to the world of technology. It's kind of a weird thing, right? And so that's one of the things. Like you're sitting here and like, oh, I don't want to write out thousands of different iterations of ways that somebody could ask the exact same request. And so one of the cool things here is you can use OpenAI. And now with OpenAI, not only can people in a single language make requests using all kinds of, different phrasing or whatever else. But now OpenAI understands different languages. If you have a user that's speaking in French, if you have a user that's speaking in German or Spanish or any other language that OpenAI knows, it can now basically give you a return just as accurately as if it's in English or whatever else. And so this is one of the interesting things that you can do with OpenAI and large language models. And this is the type of thing that you really need to be thinking about. Again, I know right now everybody likes to pontificate about AI. They just won't stop talking about AI. Again, they won't tell you how they're deploying it. They won't tell you their architecture. They won't tell you what problem it's solving. It solves all of them, Eli. Eli, LLMs solve all problems. Like no, they just don't. They just don't. And so this is the kind of thing that you need to be thinking about, again, when you're dealing with AI or whatever else, is thinking about this basic level of functionality and asking, how can you add this to your solutions, again, to make it easier for users at the end of the day. You know that computers don't work magically. One of the problems, though, with users is they type stupid crap into command prompts, and then they get mad when the computer doesn't understand their stupid crap. My computer should understand this. You're just like, why? I don't understand. Why should your computer understand that? That's not how computers work, right? And so one of the things you can be thinking about with this is, right, you could add this so that if people ask non-standard requests from your system, you could send that to Open API to say, what the hell are these people asking for, right? It's not magic. It's something that you do, in fact, have to design, but it looks like magic to the end user. And let's face it, if the end user isn't screaming, that just makes all of our lives a hell of a lot easier, right? So again, this is the kind of thing that I actually find very interesting. I think LLMs are absolutely awesome for being able to parse and try to understand human language and then give us back as technology professionals something that we can actually use. Again, something like just giving us what the hell function name these people are most likely asking for is just incredibly easy. So with this, again, one of the big things we did in this class we haven't done before is we created a file, again, with all of the functions that we care about. So that's in that particular file. And then what we do is not only do we import that file, so we have access to the functions within our script, but then we also read that file into a variable value and send that up to OpenAPI to make the request that we're doing, right? And so that gives OpenAI the context for what kind of answer we're looking for. So hopefully it gives us something decent. I will warn you, OpenAI is quirky. You get some weird responses. You're just like, I don't, what, why? I don't understand OpenAI. So anyways, just kind of keep that in mind. I'm kind of showing you the demonstration here. If you're going to put this into production, make sure you put a lot of try except statements in there. You're probably going to need them. So anyways, that's about all I have for the class today. All this code will be on GitHub, or will be in some other location, in the description or the doobly-doo. So if you want any of this code, this is all for you to use. I don't think I could copyright it even if I wanted to. It's all relatively simple. Again, 50 lines of code, nothing exactly sophisticated here. So please feel free to use it. And if you want to use this as a basis for any of your projects or classes or education that you want to provide, please feel free to do that too. So as always, I enjoy teaching this particular class and I look forward to seeing the next one.